recognize for solving is you want to isolate the trig expression. Now, in some cases, you may have more than one trigonometric expression, in which case you may need to do what we did in 5.1, simplifying trigonometric expressions to reduce them to a single trig expression. So this one's fairly simple. I'm going to move over the one using algebra skills. I'm going to write over here, I'm going to have 2 cosine of x is equivalent to negative 1. And then to isolate that, I have to divide by 2. Divide by 2. Let me zoom in on this portion. And I have cosine of x is equivalent to negative 1 half. And don't forget, these are the expressions that we've done before. This right here is an angle because the input for cosine or any of the trig functions are angles. Okay. So what we have to do is we have to figure that out. And kind of like I mentioned, there's going to be two types of problems. One where you know where the angle is or you don't know where the angle is. Okay. So in this particular example, I do not know where that x is located. So I'm going to give possible locations for this. So I'm going to sketch possible x locations for this angle. So this angle x could be in the first quadrant right here. This angle x could be in the second quadrant, and I'm going to refer to it using the reference angle. And then third quadrant, reference angle, and then fourth quadrant, also reference angle. Now create the right triangles, and maybe I should have mentioned this from the very beginning, but the reason why I know it's going to be a right triangle is because if I look at the labels, I know cosine is adjacent divided by hypotenuse. If I have a triangle where the adjacent is 1, the hypotenuse is 2, that will work, and that in fact is a special right triangle that we're going to see right now. So on all these possible locations, adjacent I have to put a 1, hypotenuse I have to put a 2. And I'm going to do that for all these 4 right triangles. Now according to this right here, this one, because it's on the negative direction, is going to have to be negative. And because I'm interested where cosine of x is negative 1, not positive, I will eliminate these two. And you can make a little note on here. Why am I eliminating quadrants 1 and 4 is because cosine of x here is positive 1 over 2. And again, not negative the way the problem is indicating. Okay? Problem says it wants negative 1 half. Now based on this sketch, if I use Pythagorean theorem, I can figure out that this is the square root of 3. 2 squared minus 1 squared is 3, and then the square root of that. So I can label this, and I see the labels, and you should recognize that those are for the 30, 60, 90 right triangle. And opposite the square root of 3 should be what? Yeah, 60 degrees and 60 degrees. Now don't forget from 4.4, we have this starting location, and I have to rotate till I get to this terminal side. When I look at this this angle right here, yes, the reference angle is 60 degrees, but what is the actual angle? 120. So I want to say that x for this terminal side is 120 degrees. And repeat the steps. Start from here, rotate till I get to my terminal side on quadrant 3. How many degrees do I travel there? Well, from here to here is 180. Add another 60 degrees, 240 degrees. Okay. And in the section from 4.4, where it would ask you, I only want the answers for, I gave you this problem in 4.4, but there I only asked you, I only want the answers from 0 to 2 pi. So you would be done right there. You would say x equals 120 is my answer, x equals 240 is my answer. The only difference for today, or this lesson rather, it wants you to do all of the answers or give all the answers. So x is equal to, yes, 120 degrees, but then plus 360 degrees times any multiple of n. Okay? And I do have to indicate here that n is any integer, because if I plug in 0, I get 120. If I plug in n equals to 1, this is what's happening in the picture. I am located here. If I'm right here, if I add 360 degrees, I end up back in that same location. So this right here, that plus 360n, is basically adding, 360 degrees to arrive at the same location, which is basically giving all the coterminal angles. And if they land in the same location, or if they're all coterminal, all of those angles will produce cosine to be negative 1/2. Okay. Now let's go ahead and give the other one as well. We could say x is also equal to 240 degrees plus the 360 times n. And again, n is any integer. If they ask you for the answers in radians, let's go ahead and convert our answers to radians. Now, here's where, if you don't have a calculator, because you can see that some exams I do take it with a calculator, some of you may be having trouble with converting from degrees to radians. You might want to start, we know that pi is 180 degrees. Start, being familiar with these right here, like pi over 3, what's 180 divided by 3? 60, okay? Pi over 6, what's 180 divided by 6? 30 degrees. The other one that you may be familiar, but it's not applicable to this problem, is that pi over 4 is a 45 degrees. And what we want to look for is multiples of either 60, 30, or 45 in whatever angle I'm trying to convert. So if I look at 120, the largest multiple I can use is 60. How many 60s fit into 120? 2 of those. So 2 times 60 is 120, so I'm going to say 2, but instead of 60, I'm going to say pi over 3. So 2 of the pi over 3s or 2 of the 60s give me that, and then, plus 2 pi n. And let me just leave this n as any integer on the screen so you don't forget that. And x is equal to, what about 240? How many 60s fit into 240? Oh, yeah, 4, sorry. So 4 pi over 3 plus 2 pi n. Now, some of you may be saying, well, the 30 also fits in there. But the reason why I say use the largest one, because you could use a 30. If you use a 30, you could say, well, 240 divided by 30 is what? 8. So 8 of the 30 degrees fit in there, but 30 degrees is pi over 6. But then what's going to happen when you reduce it? It's going to give you the same thing. So that's why when I say think of these multiples down here, the 60, 30, and the 45, is always think of the largest one. That way you don't have to reduce. All right, so here would be my answers for this problem right here. And again, the only difference here is that extension of that plus 2 pi n. And where does this come from? Well, if you recall the graph for cosine of x, which you should be familiar with, let's see what's happening here. It starts off at 1, then it does something like this. Try to do a better one. And I know that this is a 2 pi marker. This is the pi. We can continue doing the markers, but I'm just going to do a couple of these periods. And remember, we're looking for when was cosine of x equal to negative 1/2. So basically what we're getting at is this point probably belongs to 2 pi over 3. This point probably belongs to the pi over 3. But then what we're doing is to get this other point and this other point, notice that from here to this other point is 2 pi. But why 2 pi? What is the period for cosine? Well, the period for cosine is 2 pi units. Okay. So that's where, it adds up, or it comes from 2 pi, and we're going to see something similar for the tangent right now.